Hello and welcome to a new episode of Library of the Week. This is part of a series of articles I write on Medium about Python libraries, and I try to do them weekly. I make a video for each article, and you can find the link to the article in the description of the video. Today I'm going to talk about Polars, a library to handle data and to work with data frames. It can achieve tasks that are similar to those that Pandas does, such as getting data from several sources such as CSV files or databases, modify the data, aggregate it, calculate summary statistics and so on, but Polars is much faster than Pandas. So let's have a look at this library. So let's see some examples on how to use Polars. The first thing we need to do is import it. So I'm going to import Polars as PL. And now we need to create a Polars data frame. For that, I'm going to read a CSV file that I have here. It is the very famous Iris dataset. So I have downloaded it from Kaggle. You can go to this page and download it. I put the link of this dataset in the description of the video, and you can also find it in the Medium article. So to create the Polars data frame, it is very similar as creating a Pandas data frame. We use the read CSV method and pass the name of the file that we want to read. And you see, I can use the .head method just like I can use it in Pandas. There is also the .tail, so the .head method will show you the first 5 rows, and the tail method will show you the last 5 rows of the data frame. You can also put a number here, so 10 will give you the 10 last rows, but it won't print them. Okay, so if you print it, it will crop it, but if you just display it, you will have the 10 last rows of the data frame doing this. There are other methods that you can use with Polars that are very similar to Pandas. One of them is the sample method. So this is very similar to the head and tail. The difference is that it will give you a sample, as the name says, so a random amount of rows within the data frame. So see, every time I executed the IDs. So this, by the way, these IDs are found in the CSV data. So this is not the index. It really is the ID found in the data here. There is a column for it. Next method that I want to show you, and that is similar to Pandas, is the describe method. This creates a summary statistics data frame. So for each column, ID, sepal length, sepal width, petal width, and species, we have the mean, the standard deviation, the minimum and the maximum values, and the quartiles, so 25, 50%, which is also the median, and 75%, and the number of lines with both the count and the null count. So we have no null values in this data frame, 150 lines because they're all filled with data, and it also calculates the statistics for the ID, but this obviously doesn't mean anything because, you know, an ID is just an identifier. The next 3 methods I want to show you are the max, min, and min, MEAN. These are also found in Pandas, and each of them will create a Polars series, just like this creates a Pandas series when it's used with Pandas, that will retrieve a column with the column of each row, and for each column, the maximum, the minimum, and the average value. So the maximum value, well, in ID it's 150, but the maximum sepal length is 7.9, the sepal width is 4.9, and the petal length is 6.9. The minimum sepal length is 4.3, and here we have the averages. And just to finish these easy examples and quick examples, I want to show you the dot columns. In this case, the DFIris description, which is a data frame we just created with the descriptive statistics, will show you the names of all the columns of the data frame in the form of a list. So we're going to use that right now. So before we start seeing the lazy frames, which is really one of the most interesting concepts of Polars, I want to show you a last operation that we can do with data frames, which is transposing them. So we can use the transpose method to do so. And I'm going to transpose the description data frame. So transposing basically means turning the columns into rows and the rows into columns. I could use just the transpose method with no additional arguments to the function. These are both optional. So if I display the iris description data frame, I have the descriptive statistics in here, and I want these headers to become a column, and to do so I have to include the header. If I don't include the header, these will disappear. And to rename the columns, if I want to give them a certain name, that is a row of the data frame, I have to include the name of the column. So in this case, it's the describe column. Otherwise, the describe column will be added as a row, like one more row, like all the others. And the columns will be named column 0, column 1, and so on. Let's in fact see how this looks without this. See, column 0, column 1, column until column 8, so there is 9 columns. And see how these values are the values I want to be as column names. So I'm going to erase this, and let's print our data frame once that it is transposed with the headers. So here we have the column, the count, the null count, the mean, and so on. And the first column is done from the headers of the previous data frame, and the first column is created from the headers of the previous data frame. Now I want to talk about a specificity of polars, which is the lazy frame. This is a concept that does not exist in pandas. It represents a sequence of operations that are not executed immediately. So it's like a set of instructions. You basically will have a data frame with rows and columns, and let's say that you, for example, want to filter it. This is what we're going to do in this example. You want to keep the rows that are only above a certain value and so on. You will declare all this and store the operations that need to be performed, so filter the values that are over 5 and so on. Store that in the lazy frame, and there is a syntax to execute all the operations and retrieve a data frame, a polars data frame, and you can even store that in a file or insert it in a database without charging everything in memory at once. Obviously our data here is pretty small, so there is no problem to handle this kind of data within data frames or use pandas for this, but well, this is just an example, right? So in the example here, I create a lazy df iris lazy frame. So this is how it's called a lazy frame from the data frame df iris, and for that I just need to use the .lazy method. And once that I have declared this first lazy frame, I can create another lazy frame that I'm going to call sepal superior 5. I want to keep the columns where the sepal length is superior to 5, and to do so I use the filter method. See how pl.call is the syntax to select this column? This is way more simple and elegant than pandas syntax, I have to say. It looks weird to me because I'm so used to pandas, but I think I could get used to this pretty quickly, right? And so yeah, this basically means that all the data that is held in this column, if it's strictly superior to 5, we keep the row. And we store the result in a data frame called result.df, and to do so we use the collect method. So this collect method is going to execute the operation stored in the lazy sepal superior to 5. And now to explain what we just did, I did the following print that you can also find in the Medium article. Here is the thing: before the use of the collect method here, lazy sepal superior to 5 is of type, and I use the type function in Python, polars lazy frame. It stores a set of instructions to return a data frame, a polars data frame, where sepal length is superior to 5. And so here are the first 5 rows. So as you can see, when I do the result.df.head, I only have sepal length values superior to 5. And you can see that the ID here starts at 1, so the first row has been kept, but we then go to the 6, 11, 15, so it's actually filtered some rows out of the data frame. So another cool thing that we can do with polars is use SQL with our data frames and our lazy frames. So that's what we're going to do right now. To use SQL with a lazy frame, we need to create an SQL context object. So I'm going to store it in a context variable, and this context needs to have a register. So the register will basically be the lazy frame. So you create a register by passing a lazy frame object, and you can give it a name. So in my case, this is going to be iris data. This is the SQL table name that it's going to have. And once that I have created this context, I can create a SQL query. So in my case, I'm going to select all the columns from the iris data, so from this lazy frame, where the sepal width is superior to 4.1 and the species is iris setosa. So I execute this, and now to store the result in a variable, so this is going to be a data frame called SQL result, I used to execute the query within the context register that I created. And the collect method is, here I am applying them both, the execute and collect, in the same operation. So this collect is what is going to actually run the query in the lazy frame and create. This is what is going to create the data frame. And I can print the result. So you see we only have two rows that satisfy the condition, where we have the iris setosa species and a sepal width superior to 4.1. Now we can save the data frame with the write CSV method. And so here we have the filter dfiris.csv, and it got saved in a CSV file. So this is pretty straightforward, just like it is with pandas. And I just wanted to finish this video by saying that you can obviously also plot the results of your data frames with other libraries. It's true that pandas comes with visualizations capabilities. It's basically integrated with matplotlib, and you can take a pandas data frame and use the .plot without importing any other thing, and it will create plots. No, you don't have that with polars, at least not yet. I don't know if it's their intention to do it one day. It is pretty easy to create pandas data frames from polars data frames. There is a method that allows you to do that. So we can imagine a situation where you use polars to do the heavy transformations, and then maybe you get a subset of data, a reduced filtered data frame, for example, which is way smaller, and then you transform that to a pandas data frame that you will eventually use to plot, or do some things that you can do with pandas maybe easierly because you know it better, or maybe because it's a bigger library with more functionalities. So that's an option. But you can also directly plot with matplotlib. For example, I have not tested every library out there, of course, but with matplotlib it's easy to plot polars data frames. And so I have this piece of code. I'm just doing a basic scatter plot. So with matplotlib pyplot, I create a scatter plot. So this is basic or classic matplotlib code. I'm not going to comment it much, but so we add a title, we label everything. I save the figure because I want to upload this to Medium. Here is here the 3 lines of code that involve polars. This syntax is the one we saw before. So this first parameter is the x values, then we have the y values, and the c parameter is for color. So what I'm declaring here is that the column sepal length is going to be my x's, the petal length is going to be my y's, and it's all the dots in the data frame are going to be colored, and they will be colored based on the petal length, and with a color map that is this one here, which is a scale of blues. So let's see how this works. Of course, you need to install matplotlib to do this. And here you have it. So that's it for today. I hope you enjoyed this video. Like it if you liked it, subscribe to the channel and click on the notification bell. It would help me tremendously. And if there is a Python library you would want me to talk about, just leave a message in the comments below and I will get back to you soon. Until next time.